Hello and welcome. In this video, we're going to be solving a mechanics question from the 2020 Jan Edexcel paper. So let's start by reading the question. This looks like we have two particles, they're connected with a pulley. So let's read and see how we're going to approach this question. The question says, I have a particle A of mass 4 kilograms is held at rest on a rough horizontal table. As you're reading, you need to take care of these keywords and know what they mean. Rough means that I will have some sort of friction on this table surface. Particle A is attached to one end of a string that passes over a pulley P. So this is the pulley. The pulley is fixed at the edge of the table. The other end of the string is attached to a particle B of mass 3 kilograms, which hangs freely below P. The part of the string from A to P is perpendicular to the edge of the table. A, P, and B all lie in the same vertical plane. Okay. The string is modeled as being light and inextensible. Light string tells me that for the same string, if that string is light, then the tension on both sides of the string are going to be equal. So this T is going to equal this T over here. And when you think about the pulley as your object, the pulley is experiencing a tension force this direction and a tension force in that direction. They're also going to be T. So basically the word light tells me that tension everywhere in the string is equal. Inextensible tells me that the acceleration on both sides of the strings are equal. So if this ball is going to accelerate to the right with some value, this ball is going to accelerate downwards with another value, and these two acceleration values are the same. This is what inextensible tells me. Pulley is being modeled as small, smooth, and light. This basically tells you that the pulley doesn't have any weight, the pulley doesn't have any friction on it. So it says that the system is released from rest with the string taut. So the string is taut means that it's fully upright, it's not slack. Okay. At the instant of release, A is 2 meters from the edge of the table and B is 1.4 meters above a horizontal floor as shown. After descending with constant acceleration for 2 seconds, B hits the floor and does not rebound. Okay, so over here, part A wants me to show that the acceleration of A before B hits the floor is 0.7 meters per second squared. Okay, first thing, in those questions, what I like to do is always draw a free body diagram. Meaning taking every single object that I'm interested in, like ball A and ball B, and drawing every single force that acts on those objects. Okay, so first of all, the tension force, think about A. Some people might ask me, why is the tension force on A is to the right? Put yourself in A's position. You are accelerating to the right because B is falling down. How is A going to be pulled? Is it going to experience a force that pushes it to the left or pulls it to the right? Of course it pulls it, and this force is tension. That's why the tension is to the right. Same as B. B is moving down. Think that you are B and you're falling, okay, and you're holding up a rope with your hand. How is that rope going to act on you? Yeah, you're going to experience a force upwards from the rope. The rope is not going to push you even more down, right? So that's why the tension on B is up. Let's think about the pulley. Over here, the pulley is going to experience, this pulley is having the weight of B pulling it down from this side. So the pulley is experiencing a pull on this side. So the tension here is downwards. Same thing. Here, A has a mass, so this string is taut and the pulley is experiencing a force to the left and the tension on the pulley is going to be to the left. So this is the tension out of the way. Let's take ball A and draw all the free body diagram, so meaning drawing all the forces that are acting on A. I like to always start with the weight force. It's the easiest one. It's just mass times G, so 4G. G here is going to be 9.8 meter per second squared because you're doing Edexcel. If you're doing Cambridge, G is 10 meter per second squared. Other than G, what do I have? I will have a normal force. Normal force, let's call it R. Okay. And over here, I will have an acceleration. A is going to accelerate to the right. What else? Since the surface is rough, A is going to experience a force opposite to motion. So if A is going to move to the right, the friction force is going to be to the left. And since we are moving, the friction force, Fr, the friction is going to equal maximum friction, which has a very distinct equation called mu R, which is the coefficient of friction times the normal reaction, which is this R over here. So my friction force is going to be equaling mu R. This is everything for A. Let's do the same for B. We already did the tension. B is going to have just one more force, the weight acting down, and is going to have a value of 3G. Anything else on B? No. This is what I like to always start with. Okay, G is accelerating downwards. When you're drawing acceleration, you draw it with two arrows, so you differentiate it with forces, and it's going to have an acceleration value of A, and this is going to have an acceleration value of A. This indicates that they have the same acceleration. Why? Ask yourself again, because it's an inextensible string. Okay, this is what I like to start with before even reading what the question wants. This is always what you should do in the beginning. Let's now see. Okay, show that the acceleration of A before B hits the floor is 0.7 meters per second squared. So remember when we said that the string is inextensible, that means that the acceleration for B is equal to the acceleration of A. The question asks the acceleration for A. So if I somehow get the acceleration for B, that's also going to be my acceleration for A, and I solved the first part. So let's work on getting the acceleration for B. Why B? Because it's easier. I can use kinematics to solve. Why? Because I know that the acceleration is constant, okay? B moved a distance of 1.4 until it reached the floor, and this took 2 seconds to reach. And I know that B started from rest, so the initial velocity for B was 0. So this all screams kinematics. So let's see how we can approach this one. So I come over here and I say for particle B, what do I have? First of all, let me take the downwards direction as positive. So anything pointing downwards or any displacement under the initial position is going to be positive, and anything opposite to that is going to be negative. As we said, U is going to equal 0 meters per second for B. S, the displacement, is going to be 1.4 meters. Is it positive? Is it negative? 1.4 meters below this line over here. So below. So under. So pointing down. And I said down is positive. So 1.4 is going to have a positive sign over here. What else? I know that time was 2 seconds. And I want the acceleration of B, which is equal to the acceleration of A, so that will solve my question. So over here, using Saviot, this is how I solve Saviot equations. I write every equation, or now I memorize them, but when I first started, I used to write every single equation, okay, in front of each letter. So let's say this letter is displacement, so in front of it, I'm going to write the equation that doesn't include displacement, which is V equals U plus AT. There's no S here, as you can see. I'm going to do the same for the rest. So this one is going to be S equals V plus U over 2 times T. This one, let me just space them around a little bit so we can see. So this one is going to be S equals UT plus half AT squared. This is very similar. S equals VT minus half AT squared. And this one is going to be V squared equals U squared plus 2AS. Let's get back to the things I have from B. Why do I write the things I have and the equations? This helps me choose which equation, because Saviot, there are 5 equations. Some students gets overwhelmed, but using this trick, it helps you choose the correct equation every time. So I have U, I have S, I have T, and I need A. These 4 are of importance to me. Which letter didn't I mention? I didn't mention V. It's not important. So straight away, I'm going to use the equation in front of v, which does not have a v. This is how I can choose my equation. So I'm going to choose this equation over here to solve. So let me do this over here. We can copy this, put it up a little bit. So I'm going to use this equation over here. So S, which is 1.4, is going to equal ut. So u is 0. So this whole thing is going to be 0 plus half multiplying a, which is the thing that I want, multiplying t and squared. Over here, I can solve for a. So 1.4 is going to equal 2 squared is 4. 4 times half is 2. So 2a. Divide 2. A equals 0.7 meter per second squared. This is my answer. This is part A of the question. So since this is acceleration of B and it equals acceleration of particle A, they are both 0.7 meter per second squared. And this is what was required for me to show in the question. So this is part A of the question. Part B is simple. It tells me just a one marker, state which of the modeling assumptions you have used in order to answer part A. Think about it, pause the video, try to know. If you chose inextensible, then you are completely correct, because this is shown from literally the line just above over here that I said AB equals AA. Why? Because they're inextensible, and that's why I know that my acceleration for A is also going to be 0.7. Good. Up until now, I think everything is clear. Everything is good. Now, let's move on to part C, where it tells me find the magnitude of the resultant force exerted on the pulley. On the pulley means that now the pulley is your object. So the pulley over here is what we are interested in. If I draw this pulley, if I take this screenshot and draw it a little bit outside, so let's say over here, this is the pulley. I have a tension on this side and a tension on that side, and they are both equal. So now the resultant force is going to be something like this, and I need the value of both t's to get the magnitude of the resultant force, which is going to be square root of the t squared plus t squared. So basically, to solve this, I need the value of the tension. So let me do that. First of all, I can get tension from doing the equations of motion to B and A. However, A is more complicated. I have more forces. So let's think about B. So let's do the equation for B over here. As we can see, I'm going to choose always, like, to do Newton's second law, so sigma F equals ma, because here we have an acceleration. I'm going to choose the direction of acceleration as my positive direction. So since acceleration is going down for B, the downwards direction is going to be positive. So any force acting downward is going to be positive. Any force acting upwards is negative. So let's do this, what I literally said over here. So let's just pull this a little bit. So let's look at B. What's happening? I have a tension force that's acting upwards, so I'm going to put in a minus T. And then I have the 3G, which is acting downwards, so plus 3G. Any other forces on B? No, that's it. Any other forces in the Y direction? No. This is equal to the mass of B, which is 3 kilograms, multiplying the acceleration, which is 0.7. From here, I got an equation that I can solve for T. So what I can do is I can move T to the other side to become positive. I can move this to this side to become negative. So I'm going to have 3G minus 3 times 0.7 equals T. And that gives me a T value of 3 times 9.8 minus 3 times 0.7 is going to give me a T value of 27.3 newtons. So that is now my T value. And if we copied what we said over here, we copied this part, moved it over here, okay? To get the resultant force on the pulley, we need to do square root of T squared, which is 27.3 squared, plus T squared, which is 27.3 squared as well. This is going to be the resultant force, and this is going to give me an answer of 38.6 newtons. I cannot forget my unit, and this is going to be the answer for part C over here. Okay, now part D tells me that the coefficient of friction between A and the table is mu. Okay, find the value of mu. Okay, now I'd like to solve part D over here so we can visualize. So let me do that. Okay, so part D. What's happening here is, now I know my tension values. Let me do the equations of motion for particle A. First of all, let me do sigma Fy equals ma. Ask yourself, do I have any acceleration in the y direction, which is up and down? By the way, this is x direction and this is the y direction. Up and down, the particle is not moving up and down, it's moving left and right. So the acceleration in the y direction is 0. So here this is going to equal 0. So sigma Fy equals 0. That means that the forces in one direction are going to equal forces in the other direction. So over here I will have my R force, which is upwards, going to equal my downward force, or the force in the opposite direction, which is 4g. So my R is basically 4g Newton. That's the first thing. Second thing, let's do the same thing but for the x now. So sigma f of x, no, sigma fx, sigma f in the x direction equals mass times acceleration. This time I have an acceleration value because I'm accelerating to the right. So this is no longer going to equal 0, it's going to equal an actual value. So let's see how we're going to do. Ask yourself, which direction should I take as positive, right or left? If you said right, you are correct, because that's the direction of acceleration. Any force to the right is positive, any force to the left is negative. So let's do that. Tension is to the right, so I'm gonna call it as positive T, but I know its value, it was 27.3. And then the friction force, which is mu r, is acting to the left, so I'm going to give it a negative sign, mu times r. So what is r? R, I just got it from the first equation. That's why I always encourage my students to do the sigma Fy first, because always you're going to get something regarding the normal force that you're going to use in the other equation. This is how I always solve. So R here, instead of R, I'm just going to put in 4g. So mu times 4g. That is going to equal the mass of A, which is 4 kilograms, times the acceleration of A, which is 0.7. From here, I can find the value of mu. I'm going to move this whole thing to the other side, get this to this side, so it's going to be 27.3 minus 4 times 0.7 equals mu times 4 times g. If I want mu, I'm going to divide by 4g, both sides. So over here, I'm going to get mu as, if I put this whole thing in the calculator, it is going to give me a value of mu of 0.625, or basically 0.63. This is the value of mu, and this is the solution to part D. Now, a tough part of the question is part E. It says, determine by calculation whether or not A reaches the pulley. So what happens is, B is moving down, A is moving to the right. B is going to take 2 seconds to reach the floor. B is now here. And A is going to be, let's say, over here or something. Okay. If B moved down 1.4, then A will also move 1.4 meters. Okay. Now, what happens to A at the moment that B hits the ground? At this moment, the string becomes slack. There is no longer tension. Nothing is pulling it. What was pulling the whole system was B moving down. The moment that B reaches the floor, tension in the string is now no more. Tension is not applicable anymore. There is no tension. However, A has inertia. A didn't hit anything to stop immediately. A is gonna continue to move a little bit. So the question wants us to know, is A going to move and stop before the pulley, or is it going to move and hit the pulley? So the way to know this is always you need to split your question into different parts. The first part, when B was falling down until it reached the floor, what happens to A? We know that A, so the distance that A moved initially was 1.4 meters to the right, because that's the distance that B fell down. This took 2 seconds. Yeah, I need to know what velocity is A at this instant. So after A moves 1.4 meters, what's the velocity of A now? So let's use kinematics again. Let's think about the things that A has. Let me take right direction for A as positive. A started with 0 velocity, so U is 0. A is having an acceleration of 0.7 meter per second squared. We talked about that. S was 1.4 meters to the right, so it's going to be positive 1.4 meters. And I want my V. So over here from Saviet, what's the letter that I didn't mention? The letter T. So straight away, I'm going to go to my Saviet equations and look at which equation is in front of the T. It's basically this equation over here. So this is the equation that I'm going to use in my question. Let's put it over here. So this is the equation. So V squared is going to equal U squared, which is 0 squared, plus 2 multiplying A, which is 0.7, multiplying S, which is 1.4. If I want V, I will square root all of that, and this is going to give me a V value of 1.4 meters per second. So now A at the instant that B hit the ground is moving, okay, with a U or a velocity of 1.4 meters per second. Now, remember I told you split your question. That was the first part. We have everything for the first part, for the first 2 seconds. We have the distance A moved, okay? So let's say this is the pulley. This is the starting position. Okay, so we know that this whole distance is 2 meters. A moved now 1.4 meters up until this point. So now, what happens to A over here? We said that the string is no longer going to be having any tension, right? So let's now draw another free body diagram for A with the new forces. I'm going to have the weight. So this is particle A. I'm going to have the weight down. A was 3 kilograms, so 3g. I will have an R, or a reaction force upwards, and I'm going to have my friction, which is going to be mu times R, because I'm moving still. So friction is max. Oh, sorry, A is 4 kilograms, so this is going to be 4g. 4g. Now, think about the acceleration. Over here, on the left and right, I have a resultant force, which is mu R, to the left, right? I have nothing to the right. If my resultant force is to the left, 100% my acceleration is going to be to the left. Imagine A is moving to the right and something is pulling it back. So A is going to start decelerating, or basically accelerating to the left. So this is my new acceleration. Let me do sigma f of x equals ma for this new part, because I'm going to have a new acceleration value. Whenever anything changes, whenever a force is deleted, force is added, an angle changed, blah, blah, you need to draw a new free body diagram, because values change, R changes, A changes, or whatever. So over here, actually, let me do sigma f y first. Sigma fy is going to equal 0 because I don't have any acceleration in the up or down direction. Again, I'm going to have R equals 4g. So sigma f of x equals ma. I'm going to ask yourself, which direction should I take as positive over here? Whenever I ask you this question, tell me acceleration direction is positive, is to the left. So the positive direction that I'm going to take is going to be the same as acceleration, so it's going to be to the left. Any force acting to the left is positive, any force acting to the right is negative. Over here, mu r, we have mu from last question, mu is 0.625. So we have 0.625 times r, which is 4g. It's positive. Why? Because it's pointing to the left and my acceleration is also to the left. This is going to equal mass times acceleration. Mass is 4. Acceleration is the thing that I want. So I'll divide everything by 4. Acceleration is going to equal 6.125 meters per second squared to the left. So now this is my acceleration over here. I have my acceleration equals 6.125 meter per second squared to the left. Okay. Now I need to know how much distance is A going to move with that acceleration. Okay. So how much distance is A going to move until it comes to complete stop at rest. So now, again, let's use Saviot and type in everything that we have for A. Let's take right as positive over here. So A is going to be moving with an initial velocity of 1.4. We said that at this moment, A is actually moving with a velocity of 1.4 to the right, so it's positive 1.4 meter per second. V is going to equal 0. I'm trying to see where will A stop, right? So I want to know where will A stop, where will A have a velocity of 0, okay? So acceleration is going to be negative 125 meter per second squared. Why negative? Because acceleration is to the left. And what I want to get is my distance. What distance am I covering? So SVAU, which letter didn't I mention? Again, T, so I'm going to use V squared equals U squared plus 2AS. So 0 squared equals U squared, which is 1.4 squared, plus 2 times negative 6.125 multiply S, which is the thing that I want. If I move this negative 1.4 to the other side, it's going to become negative 1.4 squared equals 2 times negative 6.125 S. Divide 2 times negative 6.125 from both sides. 2 times negative 6.125. This is going to cancel with this. Putting this in the calculator is going to give you a value of, an S value of 0.16 meters. So that tells me that A continues to move after the string is slack, after the tension is gone, is going to continue moving 0.16 meters until it comes to a complete stop. So right now I need to see from the beginning. A moved 1.4 meters and then another 0.16 meters. That's a total distance of 1.4 plus 0.16 is 1.56 meters from the start. The pulley is 2 meters away from the starting position. Does that mean that A is going to hit the pulley, or is it going to stop right before the pulley? Yes, it's going to stop before the pulley because it moved 1.56 meters until it stopped, and the pulley is 2 meters away from it, so we have a little bit of distance between them. You can get it by doing 2 minus 1.56 meters. Let's say you calculated S total as 3 meters or something. So A is going to continue moving over here. That means that A is not going to stop before hitting the pulley. So now you should say in your answer that no, A is going to hit the pulley. However, in our scenario over here, to completely solve it, A is not hitting the pulley since S total is equal to 1.56, which is S total less than the 2 meters, which is the distance between the pulley and the starting position. So this is how to approach this question. Always in these questions, try to divide sections, okay, in order to visualize everything. And I really hope this video was helpful. Thank you so much for watching. Please leave your suggestions and questions down below. I'm going to answer them. And yeah, have a great day.